Yeah, we have
Yeah,
slides.
wonderful. Yeah, we're good. Okay, now it's 5 minutes past the hour, so I guess we are good to go. Hey everyone, welcome back to this seminar, or maybe you're the first timer. So in that case, welcome anyway. I'm very happy to introduce our today's speakers. I'm very happy to have Danny Digg and his PhD student Melinda from different universities, I guess. No, University of Colorado Boulder. So yeah, I guess Danny is located in a different place, but anyway, for me, this talk is a particularly interesting one because we, at some point, like back a year back, I guess, we had some kind of a rivalry in this direction. So we were working on very close project, and Danny and then his wonderful students, they beat us in this, and I'm very interested to look and to listen to this talk. I'm very happy that it actually went as good, maybe even better than our project. So yeah, without further ado, Danny, Melinda, please go ahead.
All right. Yeah. Thanks so much, Timofey, for the nice introduction and giving me this opportunity to present with Melinda today, and especially to do a sabbatical at JetBrains research with you and your team this year. And you know what you said, that we used to be competitors a year ago, but now we are friends. We are in the same boat. So I think this is what great people do. You know, they can see other people, and it doesn't matter that ideas came forward and implemented by other people or by us. They care a lot more about advancing the science and the community, and I think that's your spirit. And I say we are looking forward to join forces with you and your team and leverage all of this for the greater good. So and also we've collaborated in the past. So Oleg and Timofey and Amea, which is one of the PhD students on this slide, who is also a former student of mine. I had a paper at ICSI a year ago, 2 years ago. So looking forward to even more long-term collaboration. So before we get started on the talk today, I just want to acknowledge the day is March 8th. So it's the International Women's Day, and I want to celebrate and acknowledge and be grateful for the women that are in this talk. So I saw several women joining, and we are so grateful for your thinking, for your diverse thinking, for how you complete our thinking, so you bring a new level of energy and a more humane way of doing life. And I don't want to do like the stereotypes between men and women, but you complete us. We were missing having, and we are still missing having more women in computer science, but we are much better because of your presence in computer science, and our field is better and the whole world is better because of your contribution. So I just want to thank you and acknowledge you and appreciate you from the bottom of my heart. So I want to start the presentation now. So in this talk, we will give a high-level overview of a line of research in which we are pushing the frontier of refactoring technology so that it can help today's machine learning code developers. So this is very timely, I guess, despite all the tremendous growth of the software ecosystem that contain machine learning components. Still, the IDs and the tool support and the level of automation that the machine learning software developers have for them, it's not on par with what currently the tool support that we have in enterprise, other traditional software systems. So I want to give an overview of the research that we are doing on inferring common changes and then automating these frequent changes that we see in Python machine learning software systems. And then I will pass the baton to my PhD student, Melinda, and he's going to give most of the presentation. So we collaborated this research also with my former PhD student, Amea, as I said, who has collaborated in the past with Timofey and with Oleg. And Amea is now working working at Uber Research. So also one more thing, before one more thing, we're looking forward to have an engaging conversation at the end of the talk. And during the presentation, I want you to think about which of these ideas, tools, data sets that we present, you can leverage in your own projects. Right? So think about how can we, if you're from JetBrains, I know we have visitors from elsewhere, from all over the world, but for the people from JetBrains and other IDs, how can we move these research ideas from academic research into an ID for more significant impact? Like I want us to have a dialogue and a conversation. What would it take for us, and how can we, what else we need to do? How can we go the extra mile to have that kind of impact? I want you to think about maybe what are some of the performance, scalability, maybe other pragmatic aspects that you ask us those hard questions, so that if we solve those hard questions, we can move this research into the ID and, as they join forces with you. So, okay, so let's get started then. So this is not news for this group of people here. So we enter into a new era of computing, which people refer to software 2.0, right? So in this new era, programmers augment traditional software with programming with learned models. Like, so the engineers, instead of hard coding functions from scratch, they amass a huge training data set and feed it into a machine learning algorithm that will synthesize an approximation of a function, and the definition, the partial definition of the function, is that training data. So in this era, in software 2.0, people are using TensorFlow, scikit-learn, Keras, PyTorch, a lot of those high productivity libraries. And Python is becoming the lingua franca for developing these machine learning powered systems. And this is true both in the commercial and also in the open source. So in our formative study that we presented at the ACM Transactions of Software Engineering, we conducted the first and the largest, to date, the largest study of the challenges of evolving machine learning ecosystems. So to conduct this study, we performed static analysis, mining repositories, 3,000 top repositories in machine learning open source GitHub systems. We also surveyed hundreds of machine learning developers. And we found out that one of the findings is that the ratio of the new Python projects that use machine learning libraries increased from the 2%. So this is the green slice in here. So in 2013, it was just 2% of the new projects starting in Python or machine learning related. And in 2018, by 2018 was already half of them. And now it's actually more than half. And then also one of the main key findings is that, you know, software 2.0 is here to stay. So now this is not a passing fad. This is lots of people, companies, researchers are heavily investing resources, and have seen a huge impact in the society. And one of the main findings of our work was that the evolution of machine learning systems face unique challenges that are similar, but also very different from traditional software systems. So, for example, it is widely known that at least 2/3 of the software development costs are due to software evolution, right? So some industrial surveys claim that the cost because of software evolution is even more, like in the 90%. And so this is for everyone who has been traditionally developing software. We know that we need to constantly change the software, to use newer framework library APIs, to modernize the code, to fix bugs, to add new features, and doing all of this all over again. So this is part of the daily life. In the case of machine learning systems, let's say in software 2.0, and now developers also need to make repetitive changes also to data and also to the machine learning models. So in addition to changing the source code, so if you think about it, adds 2 extra axes of complexity and changes. So this makes the evolution of machine learning code even more expensive than is already for traditional software systems. So in our TOSM paper, we found out that machine learning developers need lots of support from tools, despite the fact that many of them are experts in the data science and in the domain that they try to solve. They are not professionally trained as software engineers. So the tools for evolving and developing this machine learning code are still in infancy, say, relative to the tools that we have in enterprise development. So our approach is to come alongside the machine learning developers and to bring their tool set into the 21st century. So we want to bring many of the advances, in our case, that we've seen in the refactoring community, to bring them to the Python machine learning system. So our approach is to offer interactive, human-driven program transformations that put the machine learning developers in the control, in the seat, right? And let software tools and the IDE do all the heavy lifting, do all the computing and remembering and changing of the code. So in the long term, we want to mechanize many kinds of changes that are required when using these machine learning libraries and frameworks. So to start on this journey, we first conducted some formative studies to understand what are the common changes, software changes that people often perform when working with machine learning components. And then next, grounded on these formative findings and studies, we designed, we implemented, we evaluated, we deployed these tools as interactive program transformation tools. But unlike in traditional refactoring systems in the IDEs, in which all the analysis and all the transformation is hard-coded for each refactoring kind, and I know because I've been contributing to these IDEs in the past, this time, our approach is to infer these transformation rules and the transformations from many exemplars that we see in open source code bases. And then we want to synthesize and apply these in new code locations and new target sites. So we hope that this presentation, these ideas provides inspiration for people at JetBrains and at other IDEs. And this might be a fresh perspective of how to automate some of the software evolution part. And we hope that it will increase the program's productivity. So on this journey, our first publication in this line of work was published, this paper that I mentioned, a transaction software engineering. TOSEM, it is called Understanding the Software 2.0. This paper discusses many of the best practices that machine learning developers use in their ecosystem. What are some of the unique challenges as they're evolving machine learning systems? And in the second paper in this line that we published at ICSI last year, it's called Discovering Repetitive Code Changes in Machine Learning Systems. We went even more further in depth, and we did an investigation of what are the repetitive, low-level code changes that occur, code changes and coding idioms that occur in machine learning software systems. And this paper paves the way for machine learning developers, and it sheds even further light on how to support them with the automated tools. And then the third paper in this line of work, it's PYEVOLVE, which we're going to present at ICSI in Australia in a couple of months. And yeah, if you're coming to ICSI, please type something in the chat so that I make a point to be with you at ICSI in Australia, and me and Malinda will be there. So in this third paper, we introduce an approach to transplant some of these best practices that we discovered in open source, repetitive common changes, to transplant them into new Python machine learning systems. And my PhD student, Malinda, is the one leading all of this, the research on all of these papers. And this research was very well received by the community. So I'm very proud that Malinda won the gold prize at the ACM Student Research Competition at FSC. And so this shows that the research community thinks it's an important practical direction. And I'm even more excited about the potential of bringing some of these ideas into PyCharm and other IDs that JetBrains works on and other companies work on. So let me pass on the baton now to Malinda. He will give a more in-depth presentation of these topics, and then at the end, I will take the baton back at the end of his presentation and will facilitate a discussion. So
okay, thank you, Danny. Let me share this around. Can you share the slides now?
Yep.
Yes, all good.
Thank you. How about the blue line? Is it like when Danny presents, there's a blue line in the screen?
Yes,
so
it's gone. It's gone also. Yes.
Okay.
No, everything's fine.
Oops. Okay. Yeah. So
I have a blue line. Okay.
green line.
Okay, Malinda, it's all yours now.
Okay. Let me. Okay. Yeah. Thank you, Danny, for the detailed introduction about the project. So I will present the project from this slide onward. So the software developers often find themselves repeating the same code change across multiple projects. So this process can be time-consuming, error-prone, and as it requires manual intervention, and it can also lead to inconsistencies in the code quality. To address this problem, our goal is to empower Python machine learning engineers with tools that automate repetitive code changes. So on our way to our goal, so we have developed this end-to-end pipeline that's automatically mine repetitive code changes and then transplants them to other ML codes. This pipeline comprised of several steps, including pattern mining, validation, and then the code transplantation. The first step in our pipeline is code mining. It involves developing a repetitive code change miner. We develop RCPAT miner for this purpose. It automatically mines thousands of software repositories for code change patterns. We use static analysis to identify the repetitive code changes in these software repositories. The next step is to filter out the profitable changes. So there could be like some patterns that might not make sense to automatically transplant to software systems. To filter out those profitable changes, we need a filter that select the profitable changes. The last step is about transplanting the pattern code change patterns into the software systems. This involves replacing the relevant code snips on the code change patterns, identify the miner. For this purpose, we develop PYEVOLVE. So in terms of progress, RCPAT miner is developed and published in ICSI 2022, and PYEVOLVE is accepted in ICSI 2023. And the design of the filter is currently an ongoing project. In today's presentation, we do not intend to go into details about the entire pipeline, but we would like to focus primarily on the PYEVOLVE. Before diving into details of the PYEVOLVE, I would like to give you a quick overview of RCPAT miner. I believe this will help you to understand the nature of the code change patterns that it mines. The RCPAT miner is a graph-based repetitive code change miner. It builds graphs that represent a code change and then mine repeated subgraphs to identify the repetitive code changes. That's the high-level overview idea of RCPAT miner. To evaluate the performance of RCPAT miner, we ran it on 1,000 highly rated ML repositories, and it extracted 20,000 code change patterns. We then performed thematic analysis on the first 2,500 top frequently repeated code change patterns, and we identified 4 major trends on how. I pressed the wrong button. On how developers evolve their ML code bases. We mainly identified 4 different trends of repetitive code changes in ML codes. So in the paper, we identified them as CPATs. This survey revealed that many developers often dissolve for loops for a domain-specific abstraction, mainly due to performance reasons. For example, using vectorized computation instead of for loop-based computation has led to significant performance gains. So another trend that we observed was the transform to use the context managers. Developers utilize this technique to effectively utilize the resources. The third trend that we identified was updating API invocations, such as API migrations. And lastly, using advanced language features like list comprehension was another trend we identified based on our survey results. So survey results and the static analysis. So according to survey results, dissolving for loops had the highest demand for automation among the developers. So since like several people in the audience today are from JetBrains, the company that makes IDs in the world. So we hope that these needs for automation provide some inspiration for the new tool features in IDs like PyCharm. So pattern mining is a crucial step in our pipeline that allows us to identify recurring trends and patterns in large data sets. However, this process can often be time consuming and laborious, especially when dealing with a vast amount of data. So unlike academics who just publish papers, some of you might deeply care about the practical aspects such as runtime, performance, and scalability of these tools. So our performance evaluation on a modest and consumer laptop from 5 years ago show that PYEVOLVE analyzed 1.16 million methods in under 19 hours, and it makes an efficient tool to code pattern analysis. These metrics would be much better if we ran on a dedicated server that is more modern. So I'm looking forward to discussion at the end of the presentation and see what you think think as an acceptable performance. So I believe that you now have a basic understanding of RCPAT miner. So now I would like to focus on the PYEVOLVE from this slide onward. So this is the high-level overview of PYEVOLVE. PYEVOLVE takes two inputs. Example code. The one input is example code changes produced by RCPAT miner as input, and then a project that you would like to apply the changes to. Then the tools output and improved project that incorporate in the input changes. So this is the high-level overview of PYEVOLVE. So PYEVOLVE is a program that utilizes transformation by example technique. To help you better understand this technique, let's consider this example from Excel sheet. So it is likely that many of you have experience with Excel sheets and have encountered the flash fill feature. In this example, the system observes how the user writes first and last names in the example, and then uses that information to infer the rule for extracting first name and last name from the full name. Then this rule can be applied to renaming the remaining example to complete them automatically. So this is the basic idea of transformation by example. Transformation by example has been used by researchers to automate code transformations. So API-Fix is a recent tool that uses these transformation by examples to automate the code changes in Android code bases. It takes code changes as input and infer transformation rules. So API-Fix can automatically apply these rules to similar other changes in the other code bases. So this will enable us to automate the code changes without requiring the manual intervention from the developer. So in addition to API-Fix, there are other TB systems that have been developed for different programming languages. For example, SP-Infer is a tool that focuses on C code, and the refarser is designed to C#. And then finally, TC-Infer is used for changing between Java types. TC-Infer was developed previously in our group with the collaboration from JetBrains. So I know that Oleg and Timothy, who are here today, made a great contribution to the TC-Infer. All of these tools, so these are like just few tools that you employ the TB technique, but all of these tools use the same basic approach of deriving transformation rules from the code examples and apply it to various languages and types of the codes. So our tool, PYEVOLVE, also use TB to automate the code changes, but it also enhances the TB technique. Now let's dive into how we utilize the TB. So I would like to use an example from this slide to illustrate some fundamental concepts and how PYEVOLVE enhance the state of the art, and show how PYEVOLVE enhance the state of the art. So in this particular example, a developer has made a significant improvement to a machine learning code base by switching from for loop based sum computation to NumPy.sum. So as shown in this slide, when we input the change into TBE system, the transformation by example system, it generates a rule and a guard. The rule consists of Python statements and the expression that utilize template variable. Essentially, it explains how transformation, how to transform the syntax on the left-hand side of the code to the syntax of the right-hand side. The guard, on the other hand, specify where these changes should be applied. For example, the template, when we apply the template variable, it checks whether the template variable L1 is an int. Now let's consider how we apply this rule to target code shown in this slide. The target code has a code piece that iterates a list and computes sum. This code has very similar. This code is very similar to the example that used to generate the rules. If we want to migrate this the for loop in the target code to numpy.sum, we just need to apply the rule, and then it will automatically transform the target code. So you can see that we can easily create a pipeline using a state-of-the-art TBE techniques that automate and transform the code changes in target codes. However, as we saw in the previous example, so our life is not always simple. So this slide shows an example where an existing techniques underperform. So this is another target code that iterated through an int array to compute the sum of similar similar to the previous example. So, however, this code shown in this example has a different control flow than the example used to infer the previously inferred rule. So it cannot be transformed using the previously inferred rule. We identify this as an unseen control variant, which we did not observe it during the rule inference. So since it is not observed during the rule inference, so this target code is not transformable using the previously inferred rule. So this is another example. In this particular case, apart from different control flow that we saw in the previous slide, it also has a different data flow compared to the example that we used to create the rule. In particular, the developer in this in this case, he first assigned the addition of ndif and diff variable to a variable the total before assigning it to the accumulator variable ndif. So the variable total may appear to be a redundant variable, but it can actually make the code easy to debug, which is why some developers choose to include these additional variables. So this target code is a control flow variant because it has a different control flow, and it also a data flow variant because it accumulates the variable ndif differently compared to the previous example. This variant is unseen during the rule inference, and the rule that we previously inferred cannot be used to transform this target code. This demonstrates the need for a significant upgrade to the current TBE system, when automating the code change that contain complex and control structures, which can have various control and data flow variants in the target code. So this slide shows how PYEVOLVE addressed this challenge. PYEVOLVE basically implement a rule adaptation technique to transform this code. As shown in this slide, PYEVOLVE add template variable L4 and adapt the previously inferred rule in order to transform the code given in the target code. So this is the example that we show previously, which has both data and control flow variant. So PYEVOLVE generates this adapted rule given in this slide. So it contains additional template variable to represent the additional assignment statements, as well as the another template variable to represent the variable total. We will now go over the technique on how PYEVOLVE create this adapted transformation rule in the following slides, so that they can be used to transform the unseen control and data variants that contains in the target codes. So before going into details, I would like to explain you about the fine-grained program dependence graph introduced by Guen and others. So FGPDG, in other words, fine-grained program dependence graph, is a sufficiently generalized program dependence graph that allows us to efficiently mine semantically equivalent code fragments within a code base by mining subgraphs. These graphs consists of three kinds of nodes: data nodes, operation nodes, and control nodes. Data nodes, for example, might include simple names, while the operation nodes might include the method invocations, and then the control nodes could be a for statements. So furthermore, there are three distinct types of edges within FGPTGs: control edges, data edges, and definition edges. Control edges represent the control flow, while data edges represent data flow. Definition edges, on the other hand, help to define the role of a specific variable definition within the graph. These edges can be further divided into receiver, reference, and parameter. So we use FGPTG to understand the code structure that match the rules, and then adapt the rule accordingly. The first step of our core algorithm is to determine the possibility of applying the rule in a code. So if there is a possible opportunity, then the next step is to learn the code structure. We first create the FGPTG of the left-hand side of the rule. To do this, we extended the FGPTG introduced by Nguyen et al. By adding nodes that represent these template variables. Then as the next step, we create FGPTG for the target code. Then we mine the subgraphs to determine whether there is an opportunity to apply the rule. So if there is an opportunity, we then learn the nodes and their locations that require to be transformed by applying the rule. So here to find the data variant of the example, we also transitively match the nodes through the data edges that have we are able to match the template variable L1 to the data nodes here in the NDIF. So you can see that the match subgraph could be a disconnected graph in the target code. Now we know the code location that need to be transformed from the previous step. The next step is to generate the adapted rule. So I will explain the core algorithm using an example in this slide. The first step is of generating adapted rule is to retrieve the code snip that match when we mine the subgraphs. Then the next step is we rename the matched variable using the respective matched template variable. So that here we found these matches during our subgraph mining steps that I explained you in the previous slide. Then we add the new template variable to represent the represent the statements that do not have any other match nodes, but that always between the statements that contain the match nodes. So here we rename the L7. Then as the next step, we rename the final data nodes that transitively match during the subgraph mining techniques. Here in this case, the variable total. The last step of this is to create the adapted right-hand side of the rule, where we replace all the matched nodes with the right-hand side of the rule. In this case, we replaced the assignment statement L1 equal NP sum from the match statement in the left-hand side. At the end of these steps, we'll have the adapted rule, which we can use to transform the target code. This rule enables us to transform the variables, transform the variants which we did not observe during the initial rule inference. So during our evaluation, we focus on three primary research questions. The first question aimed to evaluate the effectiveness of our code transformation performed by PYEVOLVE. Code transformation can introduce errors or unexpected behaviors, which can have serious consequences for the functionality and reliability of software systems. Therefore, it is crucial to evaluate the effectiveness of the tools that automate the code transformation, such as our tool PYEVOLVE. So, the second question is basically aims to evaluate the contribution of our data and control flow rule inference essentially our rule adaptation techniques to overall effectiveness. So, and the third research question is here to evaluate how the actual developers find the changes made by PYEVOLVE is useful. So these are the main research questions that we use to evaluate our technique. So under this research question, we evaluate the effectiveness of our PYEVOLVE. So our research question 1 is, what is the effectiveness of PYEVOLVE in generating the correct code transformations? We make use of dataset of the already performed code transformation in real-world codes extracted by RCPAT miner. So RCPAT miner output code change patterns that consist of 3 or more code change instances per pattern. So we use cross-validation, which involve learning from one change and then applying the change to other changes that fit the patterns. Then we compare the change made by PYEVOLVE to the change found by RCPAT miner in real-world code base to check whether the transformation is correct or transformation is correct. The PYEVOLVE performed more than 40,000 transformation in total, and it achieved 97% precision and 94% recall when it performed the transformations. So our next step involves evaluating the significance of our novel technique when transforming unseen data or control flow variants. To do this, we choose 20 highly rated projects that include top-rated machine learning codes such as TensorFlow, Keras, and scikit-learn. We then transplanted code change patterns to these selected projects and manually verified whether the code change were data or control variants of the input example. We observed that in this evaluation, according to our observation, they indicate that the 70% of the code changes were data or control flow variants, which highlights the significance of our innovative technique. So without our tool PYEVOLVE, the 70% would not be able to automate it. We would not be able to automate the 70% without our technique PYEVOLVE. So in our next research question, we sought to determine the usefulness of PYEVOLVE changes for real-world developers.
Is it a little greenhouse?
To achieve this, we submitted patches for 35 top-rated projects, including but not limited to TensorFlow and PyTorch. In total, PYEVOLVE submitted 181 code changes, and 90% of them were accepted by the developers. So I would like to emphasize that even the most optimized best-in-class projects like TensorFlow, PyTorch, so PYEVOLVE were able to find numerous opportunities to improve their code bases. So in addition to that, the developers praised the PYEVOLVE changes. They cited that improvements to code efficient, that our improvements because of our improvements, they were able to improve the efficiency and the cleanness of the codes. So additionally, some were surprised to discover that our tool could detect hidden code change opportunities that were deeply buried inside the code bases. Now, I would like to discuss about both our ongoing work and the future plans. So as previously highlighted, we cannot simply transplant the code changes because they repeat. We need to consider which factors developers prioritize when deciding to transplant the code changes, and then we determine which changes are profitable to integrate into code bases. To achieve this, we currently in the process of building a filter. So this is kind of like an ongoing project. In addition to that, when we identify an opportunity to apply the code changes, there may be instances where we do not achieve the desired improvement based on the context of the code. So additionally, it may not be safe to transform the identified location. To analyze the identified code opportunities to apply the code change and decide whether to apply it or not, we are building another component inside the PYEVOLVE to determine whether the opportunity is safe to transform or not. So in addition to the work explained in the previous slide, we have a plan to integrate AI support to our tools. So we have we have witnessed the creativity of LLM models, especially the GPT models, when suggesting the code changes that can be improved to improve the code. So while these models are very creative and they suggest changes that resemble expert code, the LLM might not be safe to make the changes in the code. So we plan to integrate their creativity, but to actually perform the transformation with IDEs or with our tool PYEVOLVE. With this, I would like to conclude my presentation. So in summary, we present a pipeline for mining and automating code change patterns in software systems, which we implemented in a tool called PYEVOLVE. In this study, we specially focus on ML codes, but PYEVOLVE can be used to transplant code changes for any Python systems. And it is not specific for machine learning codes. So PYEVOLVE was tested with 40,000 transformation trials and achieved 97% precision and 94% recall. We discovered that 70% of the PYEVOLVE's code changes were data or control flow variants of the example used to generate the initial transformation rules, and it demonstrated the importance of our rule adaptation technique. Furthermore, real-world developers found the PYEVOLVE changes useful, and they accepted 90% of the changes submitted to top-rated projects. And thank you so much. With this, I would like to open the mic for the questions.
All right. So yeah, thanks so much, Melinda. So here we started with, we put some questions to sort of break the ice this is just a suggested list, of course. People can change this list, add many other questions that we haven't thought about, but here are some of the questions that we first seeded for the discussion, and we grouped them into more general things like which of these ideas, data sets, projects resonate with what they're currently working on, and that's the number one. Number three, also some connections with the Python change miner that I think was Timofey mentioned that the group of JetBrains worked on. Other things, how can we leverage some of this into existing projects? What are some new ideas? What are some new directions that you can see? And then number two, it's more specific on some discussion on what would it take to integrate PYEVOLVE into an ID like PyCharm, or how we will trigger the user interaction, how we select the target code sites, how we show them to the user, how do we apply the transformation. So those are just some initial starting questions that we thought would be useful for people, but instead of us going one by one, we would rather see which are the ones that people are the most interested to talk about, and also maybe have your questions that are not even here.
Yeah, thank you, Danny and Melinda. That was very interesting talk. And yeah, thank you, especially thank you for this list of questions. This I think this is a nice touch to just to show the maybe future work in that kind of way, or even, I don't know, the applications of this approach. I guess while people are thinking about their questions, I can start maybe not with the question, but with the comment that when we approached PyCharm with the results of our tool and the transformations that we mined, you should understand that PyCharm is a well-established project that has a lot of users that use it for different reasons, different use cases. Some of them use it for machine learning projects, some are not. And even for people that use them for machine learning projects, it's like adding new feature to a tool like this actually means a lot. It touches a lot of people. And for the PyCharm team, it's always it's always a trade-off of adding new cool features that might engage some of the users, but at the same time, then they don't want to upset existing users. So it's always like a trade-off to be not too conservative, but at the same time, well, respect all the users, not trying to suggest things that they don't need. So in our case, we mined not machine learning transformations, but most of them turned out to be migrations from different libraries, from different versions of libraries, and from different versions of Python as well. And the cornerstone was that it would be very nice to somehow understand which users are actually would be interested in that kind of transformations, and which would not. So those inspections, or I don't know, suggestions or recommendations could be shown out to everyone, because that might be a bit too intrusive, I guess, when you just highlight, these inspections work, you highlight a fragment of code, and when you type on it on click or whatever, it shows you an option how this code could be transformed. So yeah, if a person opens their project that they've been working on, I don't know, for several years, and now they see that it's all yellow with those suggestions, that might be a bit disappointing, and some people might go to Twitter and start posting that PyCharm broke their project, and now it tells them that their code is not as good, and that kind of stuff, So it's they're a bit careful about showing a lot of transformation suggestions to a lot of people. So in our case, they offered us to build some kind of a model that would say if these transformations make sense for this particular user based on their code base and like project settings and the libraries they use and so on and so on. But yeah, we didn't go with this back then. Maybe we should right now. But still, just a concern that when we approached this, we also had like a nice list of transformations, and we worked on like efficiently applying them. But yeah, this aspect we didn't think about. So yeah, just like a comment that a perfectly fine research prototype might face very unusual things to overcome when it comes to the real product that a lot of people use and not very happy when something is broken, or I don't know, or just being told that their code is not perfect, let's say.
Mm-hmm.
So yeah, maybe having this in mind might I don't know, affect our research somehow. But yeah. Otherwise, yeah.
That's a great comment, Timofey, and I think it illustrates so much that, like many things in life, this is the same general principle that most of the challenges for adoption, it's not technical per se, but it's more how it engages the people, how it connects with the people, what's the kind of emotion that it triggers in people. Like you said, if I run a tool like this, in batch mode and starts coloring all your code in yellow and show that your code is broken and it's obsolete, right? It creates, it doesn't help people. It just say, the ID broke my code. I say, my code is perfectly fine. They don't see they put the blame not with their code, but they say, here is the ID that broke my code. So that's why we were figuring out. It's not we were figuring out. We put here like, what's the trigger? So the trigger could be instead of doing it in the ID in the background and putting these code inspections and coloring, maybe a different model could be it's either user explicit. If the user says, I'm here in this function, give me a recommendation, or maybe the instead of showing on the whole code, it only shows a suggestion in the function where the current cursor is that the user is editing. And so it's not that my whole code is out of a sudden yellow, but it's just that what I'm looking at right now, what I'm working with right now, the ID in the background figures out a suggestion for me and shows me here is a possible improvement. Right? Or then maybe moving the work even outside of the ID or more on the continuous integration. So can imagine a tool that when someone checks in their code, the continuous integration pipeline will trigger and will say, we'll check the code and say, here is a possible improvement to that, right? So that will make it more in the moment, more context aware. So somebody is unlikely to act on a suggestion on some code that they wrote 2 years ago, but on some code that they are working and editing right now, maybe if the suggestion is reasonable, they might be more able to action on it. And then the other thing that you mentioned with personalizing, right? So some people care about having the most up-to-date modern APIs. Some people don't care that much, right? And I think that's a great idea of how the IDE can be personalized. Right? Here's a profile of a user who cares about this, and here's another one that will be annoyed if you show this transformation. But maybe this other user cares a lot about performance, right? So here's one person who you only want to show performance-related improvements. Here's one person that cares about code using the most up-to-date language syntax or library APIs. Right? So if you can figure out which user wants what, right? Then what the ID will give them exactly what they want, then will be less annoying. So
yeah, exactly. I think that it's a valid direction of research that not many people actually think about, because everyone's interested in getting the best algorithm and the best approach and the highest metric score, but what to actually do with it later. Well, it's not how ICSI papers are wrote, I guess.
yes.
no offense. So yeah, that's the academia, how it works in general. So yeah, but no one says that it should be this way. So maybe some new wave of user interface research could give a new life to algorithms like this, just by fixing the angle or whatever. So yeah.
And the other comment that you reminded me, Tim, when you said there are some certain people that like things that are more like things to stay the same way and are more adverse to change. So I can think about my wife, like she's really great, but things that frustrate her is when she uses a web interface or an app and they change the interface. Like say, oh, well, this used to be in this part and this button, there used to be a button here and now they change it. I don't know where it is. So while it's fun for other people to discover new interfaces, there is a certain class of population, and you can look at this based on the models of human behavioral profile like DISC and other models that shows that some people are adverse to change and cannot force change. So this is the idea of personalization comes back, for people who are more eager to embrace change and early adopters. A whole new user interface experience. They might be willing to try it. They might be willing to. Then there are other people who say, don't break, the ID. That's how the pattern, it's exactly what I like it. And I put it exactly, I customize and I spend time, putting exactly the right pixels where I want it and don't mess up with that. And you're right, none of the academics, and speaking of myself, we usually don't think about things like that. So I see in the comments, in the chat, I see.
Yeah, I just wrote that nowadays it's the trend for users to be asked about, would you like that to be on? Would you like that to be off? even with auto-completion tools, when auto-completion interrupts the process of auto-completion interrupts the writing process. So it is advised to turn off that, to be able to turn off that feature. So we always can ask a user if he or she would like some feature to be on or off. But what I also was thinking about while listening your talk was about this human feedback. If the system would know that for sure this will help user somehow, for example, by adding some some feedback model, would it be beneficial for such system as yours, PYEVOLVE?
So Anya, I'm trying to rephrase the question. Can you rephrase the question for us again? You're saying
if we can add the model of human feedback into the PYEVOLVE, would it be beneficial for that tool?
If we ask so your idea was, instead of guessing what the user wants, why not ask them? Do you care about transformations for performance? Do you care about, or do you want to even turn on these features? Or do you...
I'm more talking about, did you like that transition, this transformation of your code? If yes, we will do it again. If no, we won't do it again.
Yeah. You can suggest something and ask the user what they thought about it, whether it was relevant, and then that's a great example of personalization. Like, that's where, instead of guessing what they want, you can ask them, what do you think about this? And I can envision some kind of a user workflow where they say, give me more like this, or people say, no, this is too annoying, turn it off, or they can disable, say turn it off completely, or they can say, give me more, by saying that I like this suggestion, and then maybe you figure out that, oh, the ones that they like are the ones that are improving performance. This is someone who is hardcore on performance improvement. Maybe you can turn off some of the other ones. They don't care about the code being the most readable or most concise or the most whatever. They care about what's the fastest code, right?
Yeah.
So I think that could be a great idea of how not to know user and how to learn from their preferences, and they can guide you with, imagine, like a button that they can knob, they can turn on and say, give me more, or give me less, or disable.
Yeah. So that is just the thought I had during the presentation. Thank you for that. Thank you for the ideas.
That's a great idea. Thank you.
All right. Do we have someone else to comment or ask something, or maybe reply to one of those questions on the slide?
I had a random thought that these changes, but not the changes themselves, but identification of the potential locations where the changes can be applied, can be used as like an additional measure of how good the code is. For example, when we are dealing with large aggregated data sets, we can look at like red code, something like that, but we can also look at the suggestions from such tools and say that if there are many things that can be automatically fixed, then probably the code quality is lacking. But I'm not sure how fine of an idea it is, because even in well-established projects, you found a lot of places where transformations can be applied. So I'm not sure how good of a proxy this measure would be, but maybe we can think in this direction and suggest something else.
Igor, I think that's a great idea, and I can tell you that the merit, yes, it will work. So the projects where we sent patches, the reason why we selected the top best in class was because they're actively maintained, people really care about those projects. Like people, they also want to have an impact. And so the fact that we found a few hundred places across 20 projects that are maintained heavily and are also quite large projects. So it shows that even the best in class, people miss some of these improvements. But then the morale of that is not that it shows that those projects are bad, but it shows that if in those best in class projects, tools and these kind of suggestions can improve, imagine how much more they can improve in mediocre quality projects or less than average, even below average projects. And we haven't run our suggestions on those projects, but we think that if we did it on those projects, there will be I cannot give you a number how many more times, will be many more times suggestions, and it will be clearly an indicator of the quality of the project. So your idea will clearly work. We've never tried this. This would be something, Melinda, worth considering, like selecting something, looking at the tens of thousands, and not select a project from the top, but also one which is rated lower, and see what's the density of the suggestion per file or per other method.
Yeah, I think that's a great suggestion. Like, we can also think about like how developers, like in those, like, because like we had like 90% acceptance rate because we choose top rated project, and the developers accepted those changes because they care about the project. But if you think about like non-maintained, like low, I wouldn't say low rated, but like projects that rated less maintained projects. But I'm not sure how those developers care about the code, and in those cases we'll detect more opportunities to transplant, but also in the same time we will have a low acceptance rate, because like compared to the top rated project, if we assume that they don't maintain like the top rated project, so they won't, like, we'll also have the low acceptance rate on those projects.
Yeah, so we didn't want to confound the low acceptance rate. It's not something of because the tool produced a bad suggestion. It's something that the people didn't care that much. People are not actively maintaining. But I think Igor's suggestion was, so think about this scenario, like many times when people are doing empirical evaluations, and I'm not just talking about researchers, but I can envision this scenario being also useful in industrial settings. Like people will need to select some best-in-class projects, right? And they can do that to infer, to look at what are the best-in-class doing, what are some of the best practices. There can be many reasons why people want to select out of the millions of projects on GitHub. They want to select the best-in-class, right? So right now, what they are using is some sort of proxies. They are looking at the number of stars, right? The star rating in GitHub, number of forks, how actively maintained is the project, how recently maintained it is. They are looking at, maybe they can look at documentation, they can look at other things, right? So those are all proxies, and somehow combining all of those, people can come up with some filters and say, here are some of the projects we are saying are some of the best in class. And Igor's really great idea was, what if we run this tool, come up with some new metrics, look at what's the density of this recommendation per file. Like that would be another useful.
Mm-hmm.
Yeah, another thought that I just had was, people like in industry, they in academia, a lot of papers are written in assumption that developers would like their code to be better, as good as possible, but basically, right, the best possible variant of their code, which is not true in real life. So developers are not willing to get the best code possible. They want their code to be good enough, basically. That would, like, no one would invest like additional week on refactoring the code for it to be the best code possible. So if it's not readable, if it suffers from some code smells or whatever, it's all right that they can spend some time on refactoring and then apply some transformations if the tool suggests them. But when they have this inner feeling that their code is all right, this is not the time to actually suggest them anything. So how this is very like not very well understood and very subjective thing. But at the same point, I remember from my experience being a software developer and from working with others, so that if you yourself have this feeling that your code might be better, you really appreciate those suggestions. But when you are think that it's good enough, I should work on something else, and then some tool suggests you some refactoring, or I don't know, to pay attention to some fragment of your code, you get annoyed, and that's it. So when to suggest those things, it's a very good like direction to explore, and I don't think that anyone has the answer here. So yeah, again, just a thought that I had while listening to a discussion. It's not like we shouldn't go there, but yeah, just if we are targeting making developers happy, it's not making their code the best possible code might not be at some point we might just want to leave them alone with the code they have.
And there's a reason why our profession is called software engineering. Like that's the main difference between engineering and science. It's not software science, but software engineering. People make these trade-offs, like, given enough time and resources, like people are looking at, the frequently like quality of the project, the time, budget, right? So if you say, oh, you can have any two of the three, right? You can either have people, a project done on time and with budget, but lower quality, or have higher quality and on time, but not with the budget, right? So like that's the art of software engineering. It's balancing those forces, those conflicting forces, right? And just because this is a suite of tools that improves project along the quality, it could be that at some point you cross the barrier where people say the quality is good enough, and I need to move on, right? So and then the other thing is not all code is equal. Like there's some code that changes more frequently. So if I have to prioritize, if there are several suggestions how to improve the code, I will probably keep in mind also how often does the code change. Like if it's some code that, yeah, sure, it's below average quality, but it doesn't change or very rarely changes, that it's for me less priority than some other code that is frequently needs to change, either because of the business or because we have a better understanding or because we have better models or whatever we have. We are very innovative, we are very creative. There could be many reasons why people change the code, but a high frequency code will be higher priority than a low frequency code code location. So I would probably ignore giving suggestions. So there are many other, yeah, you're right. There are many other where the rubber meets the road. Like, it's one thing to publish this at ICSI and to say we have an algorithm and we show that the suggestions are useful, and it's another beast to actually put it in the hands of users and have them use the tool. And how do you not annoy them? How do you let's hear from others what other people think. This is great discussion, great ideas. I'm going to put the spot on Alex because he turned on the video. So Alex, what do you think? What are some ideas? What are some thoughts that triggered your imagination discussing this?
Hey everyone. Melinda, thank you for the presentation, and it's good to see you, Danny, here. So I don't know, it's just this discussion about the context, basically, like how frequent the code changes, or what are the needs of the developer that is working on the code base. Made me think about this really old but well, it's not directly related to ideas here. It's just continue that line of thought. To your point, this context really varies, and there was a really old blog post by Joel, who used to be a CTO on Stack Overflow and many other things. Exactly, yeah. So when it's called 5 worlds, so basically describing 5 big contexts in the software development, and basically depending where you are, most of the things you observe around you would vary, so would be different. And so what was true in one context would be almost opposite in another, and all of them are software developers worlds. And I believe since he wrote it, which was early 2000, there are a couple more worlds were created, like machine learning software would be, I guess, one of them, and server, like kind of backend server sites, serverware is another one, and I find it useful. And the point of the blog post was this: the context is often missing from the discussion, and we just try to improve the code base, right? But the devil is in those details. That's something I find myself thinking about in conversations like that. I mean, what exactly is the world? What is the context we're in? And another thing that made me think a lot, I'm not sure, I'm not sure you heard about that, but I'm not sure how many other people heard about this. Peter Nauers, in 78 or something, he wrote a paper called, what was it? Notation as a tool for thought. Am I? Basically, no, I think it's a different one. Let me look it up. So basically, he wrote a paper saying that the software that we write and the artifacts that we produce, it's just well, it's not the whole story. And a lot of important context is missing from those artifacts, even if they're very well documented, even if books are written about how to maintain this particular code base. Evolution of this code base depends on the people and the decisions that they made. Usually the rationale for decisions is not part of the code or even good documentation at all. And it's completely missing. I mean, we cannot base decision on something that is completely missing and that is so important. Yeah, I can look up the paper.
Yeah, I fully agree with both your comments. Also in the worlds of the 5 worlds, so now it's 5 plus minus several more probably.
Right.
And then also the context, the rationale, people are making changes or not making changes, or the reason why a certain piece of code is that way. That's not part of the documentation. It's more part, and I think this is sort of what people in our profession need to understand, that it's software engineering, yes, but in a way, software it's done by humans, and understanding the humans and understanding how people communicate and how people connect and what drives them. Like, here is someone who cares about quality. Here is someone who doesn't care so much about quality, but he cares about moving fast and making decisions fast. Like all of those factors that decide how people make or not make changes, and why some change, what people are more likely to make a certain kind of change, some first to change. That's why when I see like people like Agnia or Sergey or other people who are studying the human factors, the cognition factors, all of the other factors that are ultimately responsible for how the code is.
And I think particularly why I mentioned this programming as theory building, I recall the name now, programming as a theory building article, because it gives a perception of kind of what programming is, in a way that it's about building, understanding the problem domain and building the theory of, the problem domain and a solution, more than actually writing a code that implements this solution. So, and then with this kind of perspective or this view, you start seeing many things in different way. And I'm not sure how this line of research is followed up, because I think it's 78 or something when he published that. And I think it's kind of profound theory or how to think about programming, what programming is. Yeah, I would be curious to know if you know anything, if it leads.
So that reminds me of some of the work that Daniel Jackson at MIT did with. Forgot what's the theory that he it was a theory of solving problems, and he had a famous series of books in that line of work. Problem framing, or I forgot exactly what are his books called, right? Where you're right. Ultimately, the reason why we write software is not for the sake of software. It's to solve some real problems, and how you frame those problems, and how requirements engineering, and how do you understand truly what's the heart of the problem. So that's what I would recommend for people who are interested in that, to look in the kind of books from Daniel Jackson at MIT.
Thank you.
Yeah, great comments. See, someone else put something in the chat. Let's see what's in the chat. Oh, okay, it was you. Programming as theory building. Yeah, thanks for pointing the resource. All right, who else has some other comments? If not, I'm curious. I never asked people at JetBrains, but I only heard some comments about Python change miner, and I only heard that it was very slow when people mined. Does anyone who used that tool want to comment about what was their experience with mining patterns in Python, and what could have made it slow? Like for us, when we mentioned that we've done this on RCPAT miner, was from a commodity, from a common laptop, so nothing special on the hardware. And I thought even so it was reasonable to mine all the history of 1,000 projects and to find changes. And this is the proverbial looking for the needle in the haystack, right? And a lot of the time of that 19 hours was actually dealing with Python, like dealing with the lack of types, like we had to infer and retrofit back types, and done a bunch of other things like that. But I'm curious if people want to remember working with Python change miner, want to comment on what was their experience, what can contrast that with our experience with RCPAT miner.
I don't see anyone from this project except for me, and to be honest, I don't remember everything. I guess we could get back to you when we remember how it was done. It was a couple of years back, so yeah, it's been some time.
I think it was like a three years before, right? As I remember, I think he had a meeting with you. I think it's around like 3 years. Yeah.
Yes, something like that. Okay. I guess that's it. No more questions from the audience. Thank you again, Melinda and Danny. That was a great discussion and great talk. Let's continue that line of work, and then we'll see what else could be done. I guess that's a very rich direction that like a lot of people could benefit from. And yeah, thank you once again for giving this talk.
Yeah.
Okay, so
our pleasure, and thanks everyone for participating, and thanks for the engaging conversation at the end.
Thank you.
Yeah,
Thank you
thank you
so much.
everyone. Bye bye.
Thank you.